Welcome back to ArmanisMath. Today's focus again is going to be on the right angle triangles, and we are going to develop that in a way to help us reach the goal of the unit circle. So you probably have seen this before. However, it's important that we master this, build that foundation so we can move on with right triangle trig. Okay, so this is going to be the goal. The objective is going to be a continuation of what we've studied before. Here's the warm-up. It's easier if you put your chat screen to the left. You could do that by just tapping at the top left of the chat arrow, so you can just kind of hide it while you're working on this. A little bit different warm-up. This is just a little bit different warm-up. Okay, and because we do not want to, oops, 1 second. We do not want to take more time, so I'm going to put the timer here, and I believe a couple of minutes should suffice. And number 2, did anybody give you anything for number 2? Anything for number 2? $70, yes, true. 70. And if I wanted to go a little bit further down here, square root of 34. What is 34? If you want to branch this out a little bit, 34. 17 times 2. Can you get the square root of 17? I don't have a square root of 17. That's what happens to square root of 2.
Wouldn't it just be the same? Because
in this case, I am unable to do anything here. Unless if anybody of you could chime in and say something. How about number 4? How about looking at 3 times 2 over 2? I see myself looking at, I'll put the volume down here. Cool. I see myself looking at square root of 6 divided by 2, and I just pause there because there's no perfect square under the square root of 6 multiplied that is like the 4 or the 9 or the 16 or the 25 or the 36s and stuff. That's why I just stop here. Okay, that's going to be the answer for this one. Okay, yeah. Okay. Relationship of special right triangles, and this is continued from last time. We're going to continue the same journey. Hopefully today is going to be the last day for this. Unless if you guys wanted more, obviously you need to voice that in terms of the discussion that I had and tell me that you need more of that, and before we move on and continue. So it's the same objective that we have the other time. Okay. Not sure why it's not showing what I wanted to. I know this is kind of, I put this one last time, but I wanted you now to go ahead and Google real life application of trigonometry. And once you find any answer that makes sense, obviously, write down the answers in your chat so I can see what you guys come up with. It's just simple words here. Real-time applications for real-life applications for trigonometry. Let's see who's going to put in some answers first. From the top of the building to, yep, I see that. Engineering and calculus. I can't see it. You just have to look for it, Adrina. Just Googled. There were more energy, dude. There was more energy, dude. Chemistry, bond angles and relations. Okay. In terms of making that ready for a right triangle. We have this example done before. Opposite over hypotenuse is sine. Cosine is adjacent over hypotenuse. And tangent is opposite over hypotenuse. We know that the ratio is true for, here's some, you probably have seen some of this before, but which is obviously a good thing. It says fill in all the missing measurements in the triangle. So I'm going to start with number 9. This is a 45-45 triangle because of these two little dashes here. So I know this is 45, which is equally at the top. And if this is 6, this will be 6. And how do I do that? So the usual way we do this is through the Pythagorean Theorem, which is one side squared plus the other side squared equals the hypotenuse squared. So I have 6 squared plus 6 squared equals the hypotenuse. Let's just name it C. H doesn't matter actually the name, but squared. 36 plus 36 equals C squared. And 36 and 36 is going to be 72 equals C squared. C by itself is going to be the square root of 72. And I break down 72. Let me use a different color for that. I break out 72 as, let's branch it out in a tree, see what's under it. I've got 36 times 3. I'm sorry, 36 times 2. And now I take the square root of that. So square root of 36 is 6. Square root of 2 is 2. So this is going to end up with 6 square root of 2. So my hypotenuse here is 6 square root of 2. Okay, I believe all of us know this by now. However, today we're going to just push it just a little bit further. We're not just going to use Pythagorean Theorem. We're actually going to use the trig function values that we come up with, the ratios, and then use them to find missing sides inside of a triangle. Okay. Now the second one here is 8. By the way, you have to know. You really have to know where you're at. So this is 30-60 triangle, and this is 8, which is the hypotenuse. This is 4. So again, by the Pythagorean theorem, I have the hypotenuse squared, which is 8 squared, equals, let's name this guy an A or a B, doesn't really matter. Let's say I have a 4 squared plus A squared. And 8 squared, you could play with the number itself. So 64 minus, subtract that 16, both sides, it's going to give you A squared. And 64 minus 16 is 48. Going to give me A squared. And I'll take the 48 and try to chop that off by branching out like this. So 48 is going to be, can somebody write down in the chat what is 48, square root of 48? Or how do you find a perfect square under the 48? Okay, well, I see a 16 times 3. And when you take the square root of that, that's the square root of 16 times 3. Or you could separate the square root, 16 times square root of 3. Square root of 16 is 4. Square root of 3 is square root of 3. Okay. So I see A here is 4, square root of 3. That's going to be, let me just choose a different color for this dude here. 4 square root of 3. 4 square root of 3. So notice something here. Notice what's going on. This is 4. I'm not going to talk about this yet, but just wanted you to know this thing. Look at this. This is 4. This is 8. Must be some relationship here. Interesting. And this is 4 square root of 3. Very interesting. How about this dude here? Well, this guy is 6. This guy also is 6. And this guy came up to be 6 square root 2. Interesting. Okay. I'm just going to keep that in mind. Okay. What we're going to do. So in this example, I can't just use Pythagorean theorem just by itself. The reason is I have to have two sides to use the Pythagorean theorem. Don't you agree? Because you have to have a hypotenuse on that side to get the other one. You have to have 2 sides and then to get the hypotenuse. And in this case, only given one item only, which is one side, and we're given one angle, which is 60. This guy here, this is 60 degrees in here, which means this is 30, by the way. So what can I use? Well, last slide I showed you the actual definition of the cosine, and if you remember, we had done something similar in class like this, which we will be actually doing more of just in a few minutes. So I'm going to say, first of all, I'm going to use, you could write this down, using trig function or ratio. So we're going to use a trig function and Pythagorean theorem. Okay, so we're going to use both of them to find out what's going on here. So first of all, I know I have to have something that relates this 13 to the angle. And the relationship that I see here, 13, is adjacent of the 60. We talked about that last time. If you're in doubt, watch that video. But 60 has adjacent of 13. So basically, I have to use one of the cosine functions, sine, cosine, tangent, that has something to do with adjacent. And the one that we're looking at is cosine. Cosine 60 is going to be the adjacent of 60, divided by the hypotenuse. Adjacent of my 60 is 13. Hypotenuse, I don't know. So do you want to call it H? Give me in the chat. Give me what you want to call. What do you want to call this hypotenuse here? H, B, T, whatever you want to. C. Okay. I'll take C. Divided by C. So now cosine 60, again, we're going to talk about that today more, but we know it's 1/2 from last time, but we're also going to discuss that today. C. And then you just have to cross multiply. Cross multiply happens when you have equal sign between two fractions. That's when you cross multiply. So basically, I've got 2 times. If from here I have, let me put myself a line so I can keep going. I have 2 times 13 equals 1 times the C. 2 times 13 is how much? 26. Thank you. 26 equals C, which is exactly my my hypotenuse. But it says find all missing measurements. We did find the angles, obviously. This is 60, this is 30, this is 90. So I am missing this dude over here. So how do I find this dude here? Now, we could use the Pythagorean theorem. Prior to that, I can't, because I have to have 2 things for the Pythagorean theorem. So to find now this side, and give me in the chat what do you want to call this side, B, A, T, V, whatever you want to call that thing. Somebody has okay, let's have a B. I'm going to say B here. So I want to find B. So let me pause a second and have you guys work this out. You might use a calculator for 26 is going to be like a really big number. So, but can somebody at least give me the setup for this in the chat? Or actually, if you want to also speak it out loud, that's fine. Just the setup. Okay, so I have 26 squared I am going to say this is going to be 13 squared minus b squared. 26 squared is, what is that number? My goodness. 676 minus minus 169 is b squared, and that's going to give you 507. So b squared is going to give you 507. This is a 5, by the way. 507. Is this too big for that? Okay, I'm gonna choose this one. 507. Okay. Now, if it's 507, then I have to have the square root of that. So if I were to write stuff just in here, I want to break out the 507, 507. I could actually chop it off, and that's going to be 169 times 3. 169 times 3. Remember, you're looking for the biggest perfect square under that number, which is going to be the square root of that is going to give the square root of 13. So b is going to be just a second. My tool here stopped corresponding. And this was that 26? Okay. So again, I'm just noticing things. I'm just like observing things here. These things that I just highlighted, they probably mean something. That ratio means something. Okay, let's take a look at this one here. I need to fill in the missing measurements again, and this is 22. I'm inside 30/60, and I mean, this is a choice now. I know there is something that has to do with the hypotenuse. I could choose either sine or cosine, something to do with the hypotenuse. And perhaps I'm just going to go with, say, cosine. 30 or 60, doesn't matter. Is going to be cosine of 60 is going to be this dude here. Let's what do you guys want to name this here down here? Name this guy an f. So this is adjacent over hypotenuse 22. Cosine 60 is 1/2, and f over 22. Just cross multiply. 2f equals 22. 1f is going to give you 11. F is going to equal to 11. Okay, this guy's 11. If this guy's 11, then how do you get this side here? You could use sine of 60. You also could use cosine 30, by the way. Cosine 30. Or both are fine. So let's see, how can we do that? Okay. And let's say I wanted to say maybe let's just stick with sine. Sine 60 is going to be opposite of it, which is let's just give it a name, t. Just name it t. T over 22. Sine is square root 3 over 2 equals t over 22. And you cross multiply 2 t's equals, I have to use this side, I'm sorry, here. Unless if I could just scoot it down here a little bit. Can you see down there? Okay. Probably have to use the one at the top here. So it's square root 3 over 2 equals t over 2, 2. 2 square root 3 equals 2 t's. Divide by 2. T is going to equal to 11 square root 3, which is this guy here, 11 square root 3. Okay. Again, I'm just trying to see if there's a pattern here for this. There's something going on. Something's been repetitive here. Okay, and for the 45, this is 1, this is 1, and this is going to be, that's a tough one. No, it's not a tough one. Why it's not a tough one? Well, let's see. Let me use sine 45 equals, I'm going to pick this 45 here, equals Oh, what is 45 here? This is 45. I'm looking for opposite of 45, which is the one over this side here, which we call, let's say, name it H or something, over H. Sine 45 is square root of 2 over 2 equals 1 over H. Cross multiply, H times square root of 2 equals 2. Divide both sides by 2. Divide both sides by square root of 2. H is going to give you 2 over square root of 2, which is, again, it's correct but not proper. Make sure you rationalize that. That's going to give you, towards the end, you will end up with something that is good looking like 2 square root of 2 like this. This is going to cancel, and that's going to leave you with the square root of 2. So this guy here, which is H, what kind of H is that? Square root of 2. H is going to be square root of 2. Okay? Okay, that's square. H is going to be square root of 2. Okay, so I have in my brain this here. We just looked at a question where the square root of 2 here was, this was 1, this was 1, if you guys remember just a minute ago. Now my question is, what if I want to make this guy here a 1? What if I want to make the hypotenuse a 1? And obviously there's a reason for that. I'm looking to get it ready for the unit circle. So if I want to make this guy a 1, I'm going to just have to divide by itself, because 2 over 2 is 1, square root of 5 is square root of 5 is 1, x over x is 1. So my desire is to get this guy to be a 1, and if I want to do that, I just have to divide it by itself. So I'm going to take this guy, divide it by itself. Square root of 2 over square root of 2. But since this is a ratio, whatever you do to one side, you're going to affect all the other 2 sides as well. All 3 sides are going to be affected. So if you decide to do that, this also has to be divided by square root of 2, and this has to be divided by square root of 2. So looking at it from a clean perspective here, that's going to be a hypotenuse of 1. This is 45, by the way. And this is 45. And this side is going to be 1 over square root of 2, which, if you remember the very last one we done, you just have to clean this up just a little bit to make it proper. So this is fine. So if you said 1 over square root of 2, this is correct, but you make it proper by rationalizing it. So you're going to multiply it by 2. That's going to give you a 2 divided by square root of 2 divided by 2, which means I have square root of 2 divided by 2 here. Square root of 2 divided by 2. And this is the ratio that we're going to have to use. Why? Because the 1 is what we're after. We want this guy to be 1. We want the hypotenuse to be 1, basically. I want the hypotenuse to be 1 because I want to use it for the unit circle. So I'm just getting it ready, cut and paste for the unit circle. So based on this fact, I'm just going to fill in some information here. So it says sine. Sine is opposite over hypotenuse. Opposite of, choose any 45 if you'd like. Opposite of this 45 is square root of 2 over 2. Divided by hypotenuse, which is 1, which is basically going to give you the square root of 2. Square root of 2 over 2, just like that, because you're dividing it by 1. Cosine is going to be the same thing, adjacent over hypotenuse, which will lead you to square root of 2 over 2. How about tangent? Well, look at this one. If you say 2 over 2, that's going to give you 1. Square root of 2 over square root of 2, that's going to give you 1. Blah, blah over blah, blah, it's going to be 1. So because you have the sine and cosine are the same, so that's why the tangent of 45 is 1. That's the reason for that. Okay, so just clean it up a little bit. Sine of 45 is going to be square root of 2 over 2, regardless of the measurements in the triangle, regardless of that. They could be huge, they could be small. That's going to be the ratio that we're after. Cosine is always going to be square root of 2 divided by 2, and tangent of 45 is going to always be 1 all the time. I need to give like give me a thumbs up if you just got this information. Give a thumbs up, please, or yes, or something in your chat. That tells me that you got this, so I don't have to go over it again. So we can develop the 3060. I know that we've kind of reviewing, but okay. I see that. Ivan, Jenna. Anybody else? Yeah, are we getting this? Vince, I see that. Adrina, Okay. This is the 45. Now, so for example, if it says use an appropriate trig form, which is sine cosine of the sine cosine and tangent, to find the values of this triangle here. So how do I find the value for this side and this side? Well, think with me a little bit. This was a number. So basically what we need to do is, in my brain, I'm going to draw myself. Oh my goodness, that's not drawing. That's chicken scratch or something. Oh, this one here. In my brain, I'm going to have this thing here. Let's say I have this. And I have a number. This would be, if you looked closely at the slide before, a number times square root of 2 over 2. This is going to be the number times square root of 2 over 2. Okay? And my number now is 16. So this is going to be a 16 divided by 2 times square root of 2, which is how much? 16 over 2 is how much? Interesting. 8. Thank you. So 8 square root of 2. Well, obviously for 45, you only do the job once, unless if you want to do the job twice, but because it's the same. Okay, so if you actually looked closely, we have not used any Pythagorean theorem. You just used your knowledge of the ratio for 45, and that led you to the solution. You don't have to bother with the Pythagorean theorem. You just have to know the ratio. This is 45. So what about 3060? 3060 has its also own trig ratio. And if you guys remember, I have to use another tool. If you remember, in the 3060, there was something like this. This was 30. This is 60. And this is 90, obviously. And if you guys remember, there was a number here. And then a number, this, by the way, this is the number divided by 2. This is the number divided by 2 times square root of 3. So let's just play. Let's say I have 4. This is my H. So how much do you think this guy is going to be? Actually, let's start with the easy one. How much do you think this guy is going to be? Type that, please, in the chat. Just a 2. And how much would this guy be? 2, which is times that number, square root of 3. You're done with this. That's it. No Pythagorean theorem, nothing. No square root, nothing. We're good. Okay, so just remember this ratio here. So this is the golden, kind of a golden ratio used a lot in math, but this is definitely something that you need to, something that you need to look at. Let me try to make this larger. Woohoo! Woohoo! Oh my gosh. I love this. See that? See that? Is that cool? Isn't that cool? I love this. Okay. That's why I prayed for this tool a lot to work, and thank God it actually did. Okay, here we go. So just to finish this and wrap things up a little bit here, I have, this is obviously 60. This has to be 30. And if you guys remember, what was the number here? Does anybody remember? What if I wanted this guy to be a 1? So how much would this little guy be? It's half as much as the 1. Yeah, from last slide, that's half as much. This guy is half as much times square root of 3. Or you could say just square root of 3 over 2. How do you apply that into filling out this table down here? Well, you just have fun. So for example, sine 30. Well, here's 30. What's facing 30? What's opposite? It's 1/2. 1/2 divided by 1, because sine is opposite divided by hypotenuse. Hypotenuse is 1. which is very easy. So 1/2 divided by 1 is 1/2. Sine 30 is 1/2. Cosine 60. Well, you take this dude here, this dude, and divide that by the hypotenuse, which is 1, which is going to give you 3/2. How about tangent 60? Well, you take the sine divided by the cosine, or opposite over, what's tangent? What is tangent? Opposite, TOA. Opposite of adjacent, thank you. Opposite of me is 1/2, but adjacent is square root of 3/2. So let's do it here quickly. I have 1/2 divided by square root of 3/2. Well, this is same as 1/2 divided by square root of 3/2. Oh, I could just flip this here, make that multiplication, and flip the fraction, which is going to be a 2/2 square root of 3. 2's are gone, leaving you with 1 over square root of 3. Correct? Impolite. Correct, but impolite. So you just multiply top and bottom by square root of 3, which will give you a square root of 3 at the top divided by 3. Square root of 3. Okay? Now, the fun thing about the cosine, the 60, well, let's actually do it. You're going to find something interesting here. Sine 60, I'm here. I'm looking. This is my eyes looking. And opposite of me is going to be this length here, which is that, divided by 1. That's itself, square root of 3/2. Cosine 60. Well, whatever adjacent from me is this guy, which is 1/2. Divided by 1 is 1/2. Tangent of 60 is going to be opposite, which is this guy, square root of 3/2 divided by 1/2. So you're just going to have to do the same thing here. Square root of 3/2 divided by 1/2. Square root of 3/2 times square root of 3/2 times 2/1. Chop, chop. That's going to leave you with square root of 3 at the top. Square root of 3 at the top is perfect. There's nothing wrong with that. Square root of 3. If you pay close attention now, you're going to see something that is interesting. This guy is like this. So sine 30 is the same as cosine 60. Yep. Believe it or not. Cosine 30 is the same as sine 60. Very interesting. And this is how you develop yourself for the what's going to come up with the unit circle. Basically, we are massaging the triangles, the right triangles, the 30, 60, and the 45, 45, to make them look like a hypotenuse of 1, because inside the unit circle, every radius is 1. It doesn't change. It's called the unit circle, 1 unit circle. So the thing is going to be always 1 in the radius, which is our hypotenuse here. Copy and paste that into the unit circle, which we're going to discuss further next time when we meet. Before I let you go, this just by the way, whatever we talked about today is also applicable for secant, cosecant, and cotangent for those on pre-calcs. You take these ratios and then flip them. And this is the last thing we're going to end up with. There's always hope, and I do want to again encourage you to keep going. And now you guys are the best of the best. So I am happy to see you engaged. Please, by the way, nobody else can watch the videos until you send them the link. So I'm okay if you want to send them to any Math 3s. It doesn't have to be my students if you want, or any other person who might benefit from that. So feel free to please subscribe, share, like, and perhaps write comments, hopefully encouraging comments. So so keep it up. Put a smile on somebody's face today, okay? Promise me. Take care of yourself. I'm praying for you guys. You guys are awesome.